Hey guys, welcome to this week's advanced concept presentation. For this week, we're going to be using hydrogen peroxide, vitamin C, cornstarch, and iodine to demonstrate chemical kinetics, which include concepts such as oxidation and concentration and just other factors that influence chemical kinetics. So for this experiment, we're going to be creating two solutions. For the first solution, we will have our vitamin C tablets, which we would use to mix with distilled water, which is filtered. Then we add iodine to them. And for me, when I initially added the iodine solution to the vitamin C and the water, my first attempt didn't result in the solution going colorless, and as per the video, I probably didn't have enough vitamin C content. But to expand on that, the color change is explained by the conversion from iodine to iodide, and that is from the reaction with iodine um, and vitamin C, something I'm going to be expanding further or expanding later on. But once the color change happens as a result of I2 becoming I minus, or iodine becoming iodide from the vitamin C interaction, we add hydrogen peroxide to the solution to finalize solution A. Now for solution B, it is just a mixture of cornstarch and water, which is once again filtered. And filtration really serves as a process of just trying to mitigate and minimize any other contaminants or any other impurities that might be in the ingredients involved. And once we have the mixture of the cornstarch and the water, and after the filtration, we just add, similar to solution A, we also add hydrogen peroxide. So to complete the experiment, we just take this, both of the solutions that we used, and we just take half of each and put it in a container, and we just watch the magic happen. So the observable part of this experiment is going to be um, color change. And as I discussed earlier with the first solution, the when we added the iodine, initially, yeah, there was some color, but it converted to iodide. So we had a colorless solution. And obviously with solution B, just cornstarch, some hydrogen peroxide, um, and some water, it also is a colorless solution. So what we have two colorless solutions, but somehow when we combine everything, um, we have a color change. So let's talk a little bit about what's going on behind this reaction. So hydrogen peroxide, it wants to oxidize I minus, iodide, as we saw form in the solution A, back to the colored iodine, I2. But the vitamin C, which serves as our ascorbic acid, it wants to reduce it back to the colorless solution that we saw it do in solution A. But because of the addition of excess hydrogen peroxide, as the reaction is leaning towards, the ascorbic acid is essentially it's all consumed. So I2 or iodine, which we know characteristic of its, the purple hint, it's responsible for the color, and iodine accumulates. So as a result of that, the combination of iodine and iodide, it forms a triiodide complex, which then solution B, which where it comes into play, the starch, it combines with the triiodide complex, and this is what forms the blue black color, which is really culmination of everything that is going on in this experiment. And to expand on this presentation, as I added the solutions together to form essentially the dark blue purplish compound, or color rather, excuse me, it takes a certain amount of time. And if we're able to measure it in seconds and try to compare it to other things with other values and with other factors, and in reference to the lab on Friday, certain factors influence the reaction rate and reaction, and by and essentially reducing the reaction time. So in this experiment, the same applies. If we when we heated the solutions, right, or by either increasing the temperature, or if we're adding more the content, increasing the concentration, by doing that, by increasing either temperature or concentration, we are increasing the frequency of the collisions, and really just the interaction between the molecules with the increased energy. They're interacting with each other more, so the reaction rate will essentially increase, which would reduce the reaction time. So, in summary, two reactions really occur in this whole experiment. Really, two main reactions. First, we have iodine, which upon the addition of vitamin C, it forms iodide and acidic protons, is because what it is doing is oxidizing it and forming this colorless solution that we saw happen in solution A. Now, for the second reaction, with hydrogen peroxide and iodine, and or iodide and the acidic protons, where it's converting back to iodine, which is responsible for the color change, and water. So, essence, the essence of competing of iodine and iodide back and forth. That's what's really going on in this reaction. And finally, the combination of iodine and iodide, and starch, it forms this blue iodine starch complex. So this experiment not only shows chemical kinetics through oxidation, reduction, and competing reactions, but also factors that influence the rate of reactions that occur, such as concentration and temperature. And with respect to the scientific execution of the experiment, to ensure and minimize variables, it is important to run multiple trials for consistency. Also, it is important to know that there are different kind of iodines. There's different, percent of iodine. There's different vitamin C tablets. Some are chewable, whatnot, and all these little nuances in our ingredients for this experiment, can contribute to making a difference in our result. And as for example, for me, not having enough vitamin C or any erroneous measurements can contribute to the solution not being colorless, or not enough oxidation going on, converting from iodine to iodide. And that's just an example. So, central to scientific experimentation, it is important to maintain a certain standard and try to be as precise in our measurements in order to mitigate and minimize any other variables that are going on, and even the process of filtration, taking away any impurities that might be in the ingredients that could otherwise skew the data or the results. Those are all little things that are important in this experiment and in any other procedure. But in conclusion, by just using iodine, hydrogen peroxide, vitamin C or ascorbic acid, and starch, we are able to see competing reactions through oxidation and reduction, and see how they can, and this is visible through and observable through color change, along with factors of concentration and temperature influencing the reaction rate that is occurring. So with that, that is basically the main concepts that we explore in this experiment.